Okay, anybody? Comments, questions, concerns? Going once, twice, thrice. Okay, here's the bottom. Are there any questions there anyone would like me to go over? I only assigned 1 to 29 because 30 doesn't have a variable in it. Not possible. There's nothing to solve. It's also not true. Yeah. So nobody. Which means everyone got it exactly perfectly. Okay. And then the last piece was this. What is the difference between a yam and a TV announcer? The answer, of course, is the yam is a sweet potato, while the announcer is a commentator, which is a play on the word commentator and commentator. A commentator is someone who talks on TV. A commentator is just a plain old potato. I'm seeing lots of very unimpressed faces about the pun. It's hilarious. Y'all should be laughing. My grade 9s used to laugh more about those. Okay, grade 9s used to have a sense of humor. Okay, so find me this page. This block ends what time? 11:25. Here we go. Let's run. So, multi-step equations. Single step, we started with, just to kind of give you guys, my hope was just to give you guys kind of a relatively simple foray or first couple steps, gentlemen, into the world of algebra. I know it is part of the grade 8 curriculum. Some of you may have seen some of that stuff in grade 8, just getting used to the idea of bringing back the ideas of using the opposite operation of what's written to solve problems. Now, we're going to up the ante here a little bit. Things are going to get far more interesting over the next couple days. Some of you came in tutorial looking for more practice. Get it now. Here we go. Multi-step equations. We'll keep them relatively easy to start with, and then they'll get more interesting in a little bit. Multi-step equations have 2 or more operations. The or more is the part that should scare you a little bit. But if you follow the method, one piece at a time, chunk by chunk, don't try and do things in your head, don't get lost in the big picture, just focus on one piece at a time. What can I remove? You'll be fine. So these are the steps. First of all, if there are like terms, collect them. Now, it's important when you're collecting like terms, and remember the like term is the same letter with the same exponent, or numbers without letters, so constant terms. You can only collect, gentlemen, only on the same side of the equal sign. The equal sign is like a wall. You cannot go across the wall unless you're doing opposite operations. But if you have like terms on the same side of the wall, by all means, gather them together. Collect them up. Simplify those terms. Then we want to isolate the variable by moving with addition or subtraction. Then we want to isolate the variable by multiplying or dividing. Effectively, what we're doing is before, when we had a bunch of values in an expression, we were doing BEDMAS. Now, when we're solving these things, we're doing opposite operations. Opposite operations means effectively what we're doing is doing BEDMAS backwards. We're doing SAMDEB. Hello. Okay, keep going. Okay. Okay, this is what we were doing to solve earlier. This is what we're doing to isolate. going backwards. So let's do a couple examples of what that looks like. Another way to think about this is when you're isolating for a variable, we want to work from the farthest away and get rid of those things first. And so what I mean by that, things that are further away are other terms. So in this first one here, I'm going to zoom this in. I've got 5x plus 3 equals 23. So are there any like terms that I can gather together on this left-hand side here? No. This one's got an x in it. This one's just a constant term. Nothing here can be grouped. These are not like terms. And I can't reach over the equal sign. So there's not, this first step here, collecting the like terms, is done. There's nothing to do. Now to isolate this x, we have to first get rid of the things that are not part of this term. So this positive 3 here is the thing that we have to boot over first. So to get rid of this adding by 3, the opposite operation is going to be to do what? I'm going to subtract 3. And whatever I do to one side, I've got to do to the other. The reason I'm doing this is because 3 minus 3 is 0. So if this becomes 0, 5x plus 0 is just going to be 5x. And then 23 minus 3 is going to be 20. Thank you. Now, how are that 5 and the x attached to each other? Yeah, when there is no symbol for an operation in between a variable and a value, it is multiplication every time. So then to get rid of the 5, to get the x by itself, the opposite of multiplying by 5 is divide by 5. 5 divided by 5 is 1, and multiplying by 1 doesn't change anything. We're going to be left with just x. And then 20 divided by 5 is done. And now we can go back and check. Algebra is great because algebra provides us a way to check our work. So we're going to write out, here's my check. We're going to write out the question we started with. 5x plus 3 equals 23. We're going to take the value we found for x, and we're going to shove it back into that original equation. We want to put it in there by replacing this variable with a set of brackets. So we're going to have 5, bracket, bracket, put the 4 in there, plus 3 equals 23, and then we want to see if this is true. Now when I've got no variables, this is where we do BEDMAS proper. So 5 times 4 is, that is 20, plus 3. Is 20 plus 3 equal to 23? You bet. Because this is true, this must be correct. You cool with that? Comments, questions, concerns about what I've just done? Okay, next one. Same idea, but now we're bringing in division. Actually we're bringing in a few things. I've got -2 plus x over 3 equals -4. Are there like terms I can gather together on this question? Someone said no. Remember, the equal sign is a wall. I can't reach across it. These are not like terms, so whoever said that is correct. Is Aka making you uncomfortable, Hassan? Okay. So what am I going to move over first? What do I want to get rid of here first? Or what is furthest away from the term that includes our variable? The -2. So if I've got a -2 here, what am I going to have to do to get rid of that -2? I'm going to add 2. I heard it from a few of you. And whatever I do to one side, I have to do to the other. -2 plus 2, 0. That's gone, leaving us with just x over 3 equals, what's negative 4 plus 2? It's going to be negative 2. And now I've got x divided by 3. How do I undo division by 3? Well, the opposite operation of division is multiplication. So I want to multiply 3 on both sides. 3 divided by 3 is 1, leaving us with just x. Negative 2 times 3 is negative 6. I want to see the work. This is the work I'm doing here is the work you need to show me. Yes, Hassan Joe. Until I mandate it, you don't, it is I'm demonstrating this as a way for you to check your own work. Unless I specify, I don't necessarily need to see it. I want you, it's a good habit to get into, to check, because lots of you, I'll hand out a quiz or a test, and you're like, yeah, I'm checking my work. Well, how are you checking your work? If you checked your work, and I know some of you do this the same way I checked my work in high school, you just stand there, like Josh was doing on the last test, and you're just reading your own work. You're like, yeah, yeah. But the problem with doing that is if you made a mistake the first time, chances are when you're rereading it, you're not going to catch that same mistake that you made. You're verifying yourself with yourself. And if it's yourself that's making the mistakes, then yourself is probably not the best proofreader. That's why whenever I wrote an essay for my master's program, I handed it to my wife. I gave my wife the paper. I gave her the red pen. She found all my issues, which you can't do on a test. So there is an alternate way to check your work. We can take our negative 6 here and plug it back in here. Here's the check. My original question was negative 2 plus. I'm going to replace my variable with a set of brackets. And I'm going to take the value that we got and we're going to plug it back into that set of brackets. And now we're going to do BEDMAS. The first thing to do here is brackets. Well, there's no math in the brackets. There's no exponents. There is division though. What's negative 6 divided by 3? It is negative 2. Is negative 2 plus negative 2 equal to negative 4? Matab says yes. Matab's correct. So that means this value, because it gave us a true mathematical statement, must also be true. This is how, and algebra gives you a way to do it more than any other field of math. This is the way you check your work. No more sitting and staring. You've got a technique. Okay, let's do some more. How are these two questions different from what from the first two I offered you? What's the extra step here? No worries, we're good. See, the biggest issue with this is attendance for both names. Okay, how are these two questions different than the two that came prior? Austin Joe, you got to collect terms. Both of these have collecting terms as an option or as a mandatory first step. So let's take a look at this. I've got x over negative 2, and then I've got minus 7 plus 2. What are my like terms here on this question? Yeah, you can't go across the equal sign. So it's just these two that need to get grouped. You have to include the sign out front. So what is negative 7 plus 2? Thank you. We're going to get x over negative 2. Negative 7 plus 2 is negative 5. So we're going to include the sign out front. And this is still going to be equal to 6. This then is the same problem as before. What's going to be our first step here to isolate? We want to get things that don't include this first term here. What are we going to move first? We're going to move the 5 over first. Any terms that don't include the x need to get moved over first. So because this is minus 5, we're adding 5, leaving us with x over negative 2 equals what? Last step. Thank you, Scarlett. Because we're dividing by -2, to undo that, we're going to multiply by -2, and whatever you do to one side, you got to do to the other. Multiplying and dividing by -2 cancels them out. 11 times -2. And you're welcome to use your calculator for some of these simple things if you need to. But 11 times -2 is -22. Cool. Because of the limited time, I am going to skip this one, and we're going to go straight to these bottom two for the sake of time. So same idea here. The only difference between this question and the one that we just did is there are more like terms. So the like terms here are what? I've got -3x minus 4 plus x minus 2, all on the same side. So someone give me a pair, and if you recall, like terms have to have the same variables with the same exponents. So what are my like terms over here? That's one pair. The -3x and the positive x. Josh, you want to give me the other one? The -4 and the -2. So if I'm going to group these together, the -3x plus x, I'm at -3, I'm going up 1, so I'm going to go up to -2x, and then -4 minus 2 is -6. And this, of course, then is equal to 5. And then this is no different than the very first question we looked at today. To get the x by itself, I'm going to start with the furthest terms away. That's this guy here. If I'm subtracting 6, the opposite of subtracting 6 is adding 6, and whatever I do to one side, I have to do to the other. -6 plus 6 is 0. I've got -2x equals 5 plus 6 is 11. Now, we're going to get -2 by itself. Sorry, we're going to get the x by itself by removing the -2. It's -2 times x. So we're going to divide by -2 on both sides, leaving us with x equals 11 over -2. Is that fraction reducible? Then you are welcome to leave it like that. I'm totally fine with that. Some of you hate fractions. If you want to pull out a calculator and give me the decimal for that, you are welcome to. If you, yes, it is -5.5. Cool. One more question. Again, you're stopping, the expectation here, what are you doing, kids? And if you remember, the expectation here is that if at any point I have lost you, regardless of how comfortable your classmates may feel with this, please stop me. Last one. Here we go. Now we're putting the variable in the denominator. We did it yesterday a couple times. I'm not sure if I actually do that to you. Do I do that anywhere here? I don't think I do. You know what? I don't do it anywhere. So I'm going to give you a different question. Forget this bad boy. Let's scribble him out. We'll come back to that. I want to give you a different question here. I'm going to give you this guy here. N minus 8 over 4 equals -2. I want you to scribble out the question that was there, and I want you to throw this guy down. And this is the thing we're going to solve. Okay, so the difference with this one compared to the ones that came prior is that in the previous questions, when I had fractions in there, I only had the x in the numerator. With this question, I've got a whole expression in the numerator. This is how the thing will be written. Now, there are two ways, excuse me, there are two ways you can handle this question. I will demonstrate both of them for you. And then you pick one that you're comfortable with and use that method, okay? First method is this. When you've got an expression or a whole expression in the numerator, just like when we were in the previous chapter when we were dividing a polynomial by a whole number or by a monomial, you can break up that polynomial into each term in the numerator divided by the denominator. So that's going to be my first step here. I'm going to break this thing up into n over 4 minus 8 over 4 equals negative 2. This is what we did before, last chapter, when we were dividing polynomials. In this case, we have a binomial here, dividing it by a monomial. You break up the binomial, each term in the numerator, over the denominator. And now we simplify where we can. This is, the n over 4 is going to stay as n over 4. But 8 over 4 is going to become, it's going to become minus 2. 8 divided by 4 is 2. The subtraction stays. And now we can solve this thing just like we did some of the previous ones. The furthest term away from the n is this negative 2 here. So the opposite of subtracting 2 is, someone whispered add 2 to both sides. You would be correct. So I'm going to get n over 4 equals, what's negative 2 plus 2? Careful, Acom. Don't screw people up. N over 4, negative 2 plus 2 is 0. So we're going to get n over 4 equals 0. And now to get n by itself, because I'm dividing by 4, we're going to do what? We're going to multiply both sides by 4. 4 divided by 4 is 1, so that's going to give me just n there. What's 0 times 4? 0. So the answer to this question is n equals 0. Let's see if that's true. If I put 0 in here, 0 minus 8 is negative 8. Negative 8 divided by 4 is, so we're good. Okay, this is one way to do this. I'll show you the other way here. The other way to handle this exact same question is to recognize that this n minus 8 here in the numerator is a singular, it's one expression tied together in the numerator here. So what I'm going to do to force the issue here is I'm going to rewrite this question with a set of brackets around the n minus 8. So I'm going to put brackets around that numerator. And now, if I think about doing opposite operations as being like reverse BEDMAS, the first thing I have to do is, because if you, actually that should be Sam, I spelled it wrong here. That should be a B there. If you look at reverse BEDMAS, or SAMDEB, brackets are last. This is the absolute last thing we need to deal with when we're isolating. So the thing I need to do first is actually get rid of this 4. If I'm dividing by 4 on this side here, to get rid of it to the other side, what do I have to do? I'm going to multiply both sides by 4. Multiplying and dividing by 4 means these are going to cancel. And I'm going to be left with just this n minus 8 here. Because that's all I have left, I can now drop those brackets. So I'm going to get n minus 8 equals negative 2 times 4 is negative 8. And so now I've got n minus 8 equals negative 8. Now to get the n alone here, what am I going to do? We're going to add 8 to both sides. Negative 8 plus 8 is 0. So n plus 0 is just n. And negative 8 plus 8 again is 0. The result is the same, even though the path I took was different. These are two, okay, first of all, questions about either method. Okay? I don't care which one you choose to use. Whichever one you are more comfortable with, that is the one you should use. One of them is, in math, there's always a trade-off between elegance and hard work. This one, there's nothing elegant about it, but I would argue there's more work here, and it's just simpler to get your head around. This one's more elegant. The nuance is a little bit trickier, but there's less work there, and that's always the trade-off in math. So pick a method you like and roll with that. That's it. I'm done lessoning at you. You got 25 minutes. Here's what I want to task you with. There are 30 questions here. I would like you to do the odd questions, I think. Yes. Oh boy. Do I want the odd questions? There's a style of question that doesn't show up on the odd side. Yes, I would like you to do the 1 to 30 odds. And I'm going to add to that question number 16. 1 to 30 odds and question number 16. There are answers to those questions down here on the back of the next page. After you have done those questions, I have 2 of these for you. One of them is the books that were never written, and the other one is why did Gonzo walk around carrying ice cream and a pair of sparrows? I would like you to do, oh, see, I really want you to do both of them. I am going to say I want you all to do the Gonzo page. The books that were never written, the previous one, is optional extra practice if you'd like to do it. This is the harder of the 2 pages, so this is the one I'd like you to play with. So you got 1 to 30 odds and number 16 and this page here. You've got half an hour or 25 minutes to do these. Let me know if you need an assist. Otherwise, may the force be with you. Good luck. You've got an answer key for the first chunk. Go.